So I now had a new understanding of what the capabilities of the water molecule are. I had an understanding that allowed for the dichotomy. I also had an understanding that allowed for the existence of solid water under conditions of wind shear, or at least I felt I did. And I also kind of realized that the implications of this discovery weren't just limited to meteorology. They have wider application within the study of water, because I believe that this understanding is going to resolve all of the anomalies. This was the holdup. This is the thing that was holding us back. And let me right now just step you through a few of the observations or a few of the points. The mysteries that are currently part of the study of water is the space that exists in liquid water between other H2O molecules. And you know, if you get on the internet and take a look at other models of liquid water, and which show you the molecular structure, they'll show this space here, and they'll show hydrogen bonds, and they'll show a distance here. Well, that distance hasn't really been well explained. In fact, it is considered a mystery. It's considered one of the things that they work very hard to try to resolve. Well, I'm saying this resolves it. Let me step you through why or how it resolves it. It shows that when these molecules come up and form a hydrogen bond, they reduce polarity to zero. And that means there really isn't a hydrogen bond when these things are touching. Instead, there's no force. And so any kinetic energy is going to bump this thing away. But as it bumps it away, it is the polarity in both of the molecules is returning. So it's not going to get away very far. It's going to get just a little bit away, and it's going to start coming back again. And you also have to consider that that's with both of these happening at the same time, and there's going to be, you know, effects. Like one of them might be attached for a little while the other one is away, because the polarity will be higher while the other one is away. Now that explains another thing too that they're noticing about water, is that inside of water there's a lot of solid water. What did we say solid water was? Well, it's when one of these is attached and the other one is not. So this kind of gets us an understanding of how there can be solid water within liquid water. And also that's the same explanation we have for surface tension. But here's a really big anomaly. And again, this is one that hasn't been solved yet. And it's water's heat capacity. And the solution is right here. It's simply what I just described to you. As these things, as a little bit of kinetic energy knocks one of these other molecules away and sends that one off on a little bit of a thing, the energy associated with that was put into that is conserved. And so we can think of water on the molecular level, because of this strange mechanism, because of this tendency to neutralize its own polarity with its hydrogen bonds, as being a mechanism that conserves energy and that even stores energy. That explains H2O's high heat capacity. And I would challenge you to find anyone else who will provide you a better explanation than this right here.